Here the answer is Unit 7, Multiple Choice Quiz A. Unit 7, again, was differential equations, and there were 5 problems that gave people a little bit of an issue. So the first question says, Anna opened a bank account with $1,000, earned interest compounding continuously. The interest rate is 2%, and the function P models the amount of money in the account in dollars at time T. Assume Anna withdraws money from the account continuously, the rate N. Which of the following differential equations best describes the relationship between P and T? So there are two things going on here. One, that the money is growing continuously, but then also that Anna is withdrawing money from the account continuously at the rate of N dollars per year. So take your money formula, PERT, set it up, decide that the rate that the money is growing is the derivative of that, which happens to be this statement, which if you substitute in P gives you this. And maybe some people chose A, but you need to factor in the withdrawing money at a continuous rate of N. So the rate of growth is this, the rate of withdrawal is this. Correct answer is D. Next one is solving a differential equation, probably just by substitution. So there's a couple different ways of doing this. I don't know if this is the most efficient way, but I took, moved the 2y to the other side, and then found y prime for each of these functions. So x times y prime is 2 plus 2 times y. So finding y prime is pretty quick. It's just 2x. Substituting y, which is x squared minus 2 over here, you can simplify this in your head and realize that it doesn't work. Same process for this one. The derivative is 2x plus 2. Move the y into here. Simplify in your head. Doesn't work. Third one works. Derivative is 8x. Substitute this in. The 8x squared and the 2's cancel out, and that leaves you with 8x squared on both sides. C is the correct answer. Fourth one is matching a differential equation to its corresponding slope field. So just like finding intercepts by substituting in 0 for functions is pretty straightforward, substituting 0 helps you find slopes along the x or the y-axis. If I let x equal 0, then I know that the slope is a positive y squared, which means it has to be positive. So I look in the y-axis to make sure slopes are positive. These are all positive, these are all positive, these are all positive, but this down here is negative slopes, so that eliminates choice D. If I do the same thing, but this time letting y equal 0, when y is 0, the rate of the slope is negative x squared, which means the slope must be negative. These are positive slopes, these are negative slopes, and these are positive slopes. So A and C are eliminated, which leaves us with just B. Next one, use Euler's method on this differential equation. So the only thing that makes this a little bit different is that you're starting at x is 1.5 and moving down to 0, so your delta x is a negative 1/2. Set up your table, start with the ordered pair, and then do the 2 steps. Calculate the slope, find your new y value by taking the old y value and adding in slope times the increment or the delta x. First time around, slope is 2, negative 1, 2 times negative 1/2 is negative 2. Start with that. Calculate your new slope, 3. Calculate your new y, negative 3.5. Last step, new slope is 4.5. Calculate your new y. Need a common denominator. That should say 14/4, not 14/9. 14/4 minus 9/4 is negative 23/4, negative 5 3/4, or negative 5.75. And finally, the last one, another differential equation that you need to solve, and they give you 3 potential solutions. So again, we're going to take the solutions, plug them into the differential equation, and see which ones works. So for the first in blue, the second in green, and the third in red, I found the first derivative and the second derivative, and then I substituted them into second derivative minus 5 times the first derivative plus 6 times the original y is equal to 0. First one, when I substitute in and simplify, I'm going to get 10 e to the 2t minus 10 e to the 2t, which works. Second one, I get 45 e to the 3t minus 45 e to the 3t, which works. Third one, you can kind of guess that this one isn't going to work because the derivative of sine is cosine, the derivative of cosine is negative sine. So when you take the second, first, and third derivatives, you're going to get one cosine, even if the sines cancel out, which they don't, but even if they were to, you'd still have this cosine left over, so that one doesn't work. correct answer is just the first and the second.